Okay, problem 10, exercise 68. And again, for students that need the additional support, this is me working at the problem. Now you're going to see me, sort of reading to you and suggesting what to do. And the big question always becomes, is this the only way to do the problem? No, but it's the way I did the problem, all right? And that's a big difference, by the way. Somebody will say, well, I have a better way. Share it. I really do mean that. But I want to point out, you start to recognize things over time. And one of the things I start to recognize is a relationship between equation 1 and equation 2. And it really comes about by squaring equation number 1. So if you squared that, I'll write this down for you. If you were to square x plus y plus z, it's a really simple squaring problem, by the way. And what do you get? X squared plus y squared plus z squared plus twice xy plus xz plus yz. That's what you'd get if you squared that. So someone says, why would you do that? I see it in the second equation. So let's go through this over here. If you square this over here, you get x squared plus y squared plus z squared plus 2 xy plus xz plus yz equals, well, what's 12 squared? 144. Right, obviously that's pretty easy to do, but again, following instructions, what they're saying to do. And so if I did that, do I know what xy plus yz plus cx is? I think so. And I'll point out what I mean by that. We're going to highlight around. Do I know what this is? Well, xy, xz, yz is 47. I'll write that down for you. So x squared plus y squared plus z squared plus 2 times 47 is 144. Now I'm going to simplify that. And if you simplified that, what would you get? You would get x squared plus y squared plus z squared is equal to, what's 2 times 47? That's 80 and 14. That's 94. And I'm going to take that from 144. That's 50, isn't it? That's not bad. I want to point out, a lot of people look at my notes and say, I don't really even see where that is in your notes. It's right here. Right, that's important. I got that. Now, by the way, I'm just going to say that's done. I understood what they said in the instruction. I did that. I'm going to erase. I'm going to erase all this business over here. Right, I'm even going to erase this because I have it down already, right? So, it says square the first equation and multiply the second equation by 2. Well, I didn't do that, but I did get what they got, all right? And someone says, why did you? I just factored it out, all right? And let me clear what I mean by that. I just saw this thing as 2 times that, and that's fine, all right? It's something a little bit different, right? But they're still going to get 50. They did that, all right? So we got that, all right? Man, I say I got that, I got it. It says now subtract this from the last equation. Well, I'm going to take their suggestion again, and let's put this down. What's the last equation? It's x squared plus y squared minus z squared is equal to 0. And they said subtract this. Well, let me put that down. Minus x squared minus y squared minus z squared equals minus 50. And what do you get over there? Well, a lot of things disappear. You would get minus 2z squared equals minus 50. And now I know why they did that. What are they seeing now? They're seeing that z squared is equal to 50. I'm sorry, I made a mistake there. My error is equal to 25. So what's z equal to? Plus or minus 5. All right, we did that. I want to point out, I'm going to get my eraser out again. Erase this. I got this. And I want to highlight that they said that. We got this right over here. That z is plus or minus 5. We're just following their instructions about it. We're trying to learn by seeing what somebody else did to do the problem. You may now use these values for z to simplify the system. All right, let's see if we can do that. So someone says, what do you mean you want to simplify the system? Well, they're saying they're not showing much work here. And I agree with you. They're really not showing much work over here. But what I'd like to do is I'm going to start to erase things, and I'm going to try to simplify the system by taking a value of z. I want to see if I can do it. All right? So let's see if we can do that. And remember, I'm going to try one thing at a time. I can try z as 5. And let's see if we can simplify the system. And what would the first line become? It would become x plus y. Well, I know z is 5, by the way, but I'm just going to subtract 5 from both sides, and I get 7. I'm going to take the second equation down. Again, I'm using z as 5, right? So what do you get? xy plus 5y, again, z is 5, right? Plus 5x is equal to 47. But I have two equations with two unknowns now. Two equations, two unknowns. I'm actually going to use this. I'm not going to go to the next one. I'm going to use this one. And what would you get over here? Well, xy plus 5 times y plus x is 47. Do you know what y plus x is? It's 7. So xy plus 5 times 7 is equal to 47. And again, I'm just using one. I'm just using this way. You can do minus 5 later. So xy plus 35 equals 47. xy, well, that would be 5 and 7, which is 12, right? This is pretty simple. I'm going to write that down for you. I have two equations now that are very simple. And I want to point out what they are. X plus y equals 7, and xy equals 12. Well, you know what I'm going to do? I'm going to make a substitution now. I'm going to say x plus y. What's y? It's 12 over x is equal to 7. Again, I'm just using this over here. That's all I'm using. It's tough, though. Now, someone says if you do 5, you can do minus 5. I'm going to let you do minus 5. I'm just doing 5 right now. You can do minus 5. Right? We'll get to the key later. So I'm going to multiply both sides by x. What do you get? X squared plus 12 equals 7x. And what I'm going to do now, I'm going to solve it. X squared minus 7x plus 12 is equal to 0. That's pretty simple, isn't it? I can factor that. I'll point out what I mean by that. X and x. 3 and 4. X equals 3. X equals 4. Now, granted, I realize something. I don't even know where this is going here, but I'll tell you what, I know now. When z is 5, I got two results now for x. X could be what? X could be 3. Or when z is 5, x could be 4. Now, do I know a relationship to get y? I do. It's right over here. Well, what's y going to be? Well, if x is 3, y would have to be 4. And if x is 4, y would have to be 3. So I got two triples. And I'll point out what they are. One is going to be 3, 4, 5. That's right here. The order is x, y, z, by the way. And what's the other one going to be? X is 4, y is 3, z is 5. I want to claim, though, we just finished this one. It really wasn't bad. It wasn't bad at all. I'm going to start to make an erasure, though. And I want to start you on the journey. I don't know if I want to finish it, though. So why don't you want to finish things? We want you to finish things. It isn't wanting me to finish things. And let's see what I said I was going to do. go back and start again, right? So let's take a look at this thing over here. So I'll write it down again for you. So now we're going to say z is minus 5. And yeah, look at the first equation, really not that bad. What's going to be x plus y equals 17. And let's do the second equation. Looks pretty tough though, doesn't it? So xy, and let's write that down for you. Putting the z in, right? So xy, let's see, minus 5y minus 5x equals 47. Well, it looks like deja vu all over again, right? Let's put this down now. It's tough, but I can write this down. X plus y is 17. And the second equation is xy minus 5y plus x equals 47. So let's take a look. And do you know what y plus x is? Yeah, it's 17. So let's write this down. X, y minus 5 times 17 equals 47. Get my eraser out. And 5 times 17 is 50 and 35, 85, right? $47. And then xy, let's see, 80 and 40 is 120, 125, 132. All right, different number, but I'm going to pop it in. And where do I pop it in? Right over here. And what do you get? X plus y. What's y? It's 132 over x. And what's it going to 17? I'm going to multiply both sides by x. Deja vu all over again. You get x squared plus 132 equals 17x. Well, it's quadratic. I'll write that down for you. It's x squared minus 17x plus 132 equals 0. And I have to solve that equation, but I want to point out this is when z is minus 5. All right? Now, what do I know about the x in this problem? There'll definitely be two x's. It's quadratic. All right? So, how do I solve that quadratic? And you could say I'm going to try to factor it. I just don't see that happening with your fingers. So I'm going to use quadratic formula. I'll write it down for you. X equals, and it's tough. I'm not saying it's going to be easy for you. The opposite of the b, which is 17, plus or minus a really nasty root. I'll write it down for you, though. 17 squared. I'll do the arithmetic later. Minus 4 times a, which is 1, times 132. I'll do the arithmetic later. Over twice a, which is 2. I can get my eraser out. I need a little extra room, by the way. And I'll erase this over here. I want to tell you that one of the big problems with erasing things, if I'm wrong, I'm kind of wasting my time. All right? But I got to do some arithmetic over here. And 17 squared, I'll write that down for you. That's 170, 70, and 49. That's 289, right? And what's 4 times 132? Well, it's 400, 520, 528. I have to subtract them. Oh, well, that's a lot of work, isn't it? This would be 1. This is 18. I get a 9. That's a 4. That's 11. That's 3. 239. So it's minus 239. Let's write this down. X equals 17 plus or minus the root of minus 239. I want to repeat, I don't mind using calculators, but especially if you're tired, by the way. But, you know, I got a number, right? And there's two x values. Right, and the problem with getting two x values is they could be pretty tough to deal with. All right? Now, by the way, I've noticed about this over here, and I want to tell you, historically, they would not use the letter I. But nowadays, they use the letter I. So I'm going to write down what x is. X is 17 plus or minus I, that's a unit imaginary, root 239 over 2. And that's two separate x's. How do you get the y's? You're going to use this over here. Before I do that, though, I want to claim it looks pretty difficult. I know that. But I just want to check that I got this over here. The z is minus 5. Did I get the two different x values? I got this one, 17 plus I root 239 over 2, and I got this one over here. I just want to briefly go through how to do this one over here, all right? So let me just take one of them, and let me take this one over here, which is x equals 17 plus I root 239 over 2. And what am I going to do? You know, to find out the y, what I have to do is I got to do 132 divided by that number. So the y would be 132 divided by the x. Well, that's the same thing as multiplying by its reciprocal. What's its reciprocal? Well, let's write this down. It would be 2. What goes on bottom? 17 plus I root 239. All right, I hate to do it to you. I'm going to be erasing this later on, but this is, to me, it's a great answer, by the way, but I realize that, you know, it's not a good answer. And the reason for that is that most people don't want that answer listed. They want that written in the a plus bi form. So I'm going to multiply by its conjugate on the bottom. And let me write this over here very carefully. And again, this is the x number. Now, someone says, what are you expecting to get out of this? I'm expecting to get the y number out of it. And what y number are we expecting to get out of this one right over here? Which might seem remarkable, right? It may seem remarkable to you we're getting that, all right? But I'm going to write that down for you. Let's see how remarkable it is. What are you going to get over here? Times 2. And then I can multiply the top mod by the conjugate. 17 minus I root 239. Now, if you multiply the bottom by the conjugate, what are you going to get? You're going to get 17 squared minus I squared times 239. I got some work on my hand, don't I? Well, I think we did 17 squared before, right? It's 289. So I have 289 minus 239. And that's going to give me a 50, right? Let's see if I got that right. Oh, not 50. I'm sorry. I'm sorry. It's not minus 239. It's plus 239 because I squared is minus 1. 9 and 9 is 18. 8 and 8 is 16, 17. And 2 and 2 is 4, 578. I'm just copying right away. 289, 239, 5. You know what? I made a mistake. 9 and 9 is 18, 9. I'm sorry. I'm really getting... I always say you should use calculators. Yeah, maybe I should have used a calculator. And let me write that down again for you. So 9 and 9 is 18. That's 9, 12. It's 528. Sorry about that. All right. Now again, someone's just looking at it. I don't think you got the right answer. Well, let's be careful. Right, let's be careful. And I'm looking. And what am I looking at? And 2 times 132. I think I made a mistake somewhere. 200. 2 goes into that. That'll be 250, 264. And let's just do another reduction. That would be 61. I'm sorry, 66. And this goes in 132. And 66 goes into 32 2 times. Look at that. It's a miracle. What do you get over there? What they said you're going to get, which is 2 on the bottom. And on top you get 17 minus I root 239. Remarkable, all right? It's a lot of work, yeah. I point out the reason I do go through these problems, and I do use a lot of paper and pencil to go through these problems. When I type them up, it may not be sufficient. And by the way, even me talking through the problem may not be sufficient. But you know what? We got to the end. We got to the end of it. Now, certainly, I bet there's a lot of people out there looking at this saying, you know what? I think I might have a better way of doing that problem. You might, but I got to be honest with you. There's only these answers to be provided over here. 2 real, and then the complex ones. Okay? Now, again, if you want to share something with me, please feel free to reach out to me. My name is Ron. My last name is Bannon. And I can be reached at this email address, B as in boy, the @ NNON.US. Thank you so much for paying attention.